Okay, so welcome everybody. Let me first introduce myself. My name is Vida Dujmovic, and I am professor in the School of Electrical Engineering and Computer Science. And one of the reasons I'm giving this presentation is because I'm also a computer science and software engineering ambassador for the school. I'm putting this up just so in case it's very often happened that one presentation finish, and once you ask your questions, you go home, or in this case, you stay home, but in a couple of days, you may have more questions. In this case, please feel free to email me your questions. Either I will answer them, or if I don't know the answer to a question, I will find out somebody who does. So if you have questions about computer science or software engineering, you can email them to me. And if you have questions about computer engineering and electrical engineering, you can answer them to Gilbert Arbez, and his email is here. He's a program ambassador for these two programs. All right, so let me start by showing you where we are, especially because normally you would come and visit the campus, and due to the present circumstances that we all know too well, this is not possible. But the School of Electrical Engineering and Computer Science is situated in this building here. One of the nice things about building is that some of the nicest spaces in the building are actually dedicated to the students. So you see this huge space with a lot of windows. Along all those windows, there are tables where students are working and with electricity plugs and studying together and so on. So it's this part here that you see in the bottom is not office space. It's an open space where on each floor the students are using them. And on the ground floor, they have a cafeteria and big desks that they also use for working. The campus is in the middle of the city, so that's another nice thing for the students. So that's the building I was discussing where the school is situated. The professors' offices and some of the labs are on the other side. And it's in the middle of the city, so students can walk to the nice areas and don't even need to use public transit for most of the things that they need. All right, so I will talk about the programs that we offer in the School of Electrical Engineering and Computer Science. We basically housed all of, let's call them high-tech programs. There are four main programs: computer science, computer engineering, electrical engineering, and software engineering. There are also two kind of extra programs that I will mention. One of them is brand new, and I will mention them as well. I assume that many of you have questions about the differences between these four programs. I'm hopefully going to, and this comes from also from my experience from before giving these talks. So I'm going to try to emphasize the differences between these programs. During this talk, it may appear that I'm talking possibly more about computer science or software engineering, but that's only because actually I'm a professor of computer science and I know much more about that than some of the other disciplines that we have in the school. So please don't take that as some sort of a preference. It's more just that it's something I know much more about. But I'll try to give you information about all of the programs as best as I can. All right, so let's start with computer science and software engineering. Both of these disciplines are about solving computational program, designing software, and the differences would be one way to think of software engineering is a discipline where you're not only designing softwares and solving computational problems. You are also interested in how do you do it on a big scale, how you do apply engineering, design and quality ensuring processes to ensure that the big softwares can be developed. Let's think of it as kind of managerial or teamwork part of the design of big software. So there is a special emphasis on that side of computer science. So let me actually start with some example of what computer science is, what type of problems you can imagine that you're going to learn and that you study. So what would be example of a computational problem? So here on the right, you have something that looks like a graph or a map. And one of the classical computer science program, and it's used everywhere, is, for example, if I give you two locations in this map, you want to know what is the shortest path in the map. So the students already in the second year, they're going to learn how to solve computational problem, how to program them. So basically translate the solution in a way that computers can understand. Also, how do you solve them efficiently? This is what makes computer science actually a discipline, university discipline, is that you're studying how to solve problems efficiently, so as fast as possible, which problems can be solved, and so on. There are many applications of computer science, basically all domains of life, as I'm sure you're all aware. So what do we offer in terms of programs in computer science? So I'm going to emphasize what programs we offer in all four disciplines: computer science, software engineering, computer engineering, and electrical engineering. So for example, in all of them, we offer co-op option. Okay, so all our program, if the students are interested in co-op, they can opt into that option. Basically, they can do that at the moment they're applying on the Ontario system. So if they get accepted into the program, then they get accepted into co-op. If they chose that option, they can also apply in the first year. There is a difference in software engineering, and I'm going to get to that difference in a minute. So what are the specializations that we offer in computer science? We have, of course, the main computer science degree, so-called honors, bachelor's is the specialization in computer science. Another option that students have in all of our program is to choose entrepreneurship option. Is one of the very big strengths of University of Ottawa, and specifically of Faculty of Engineering. We have Canada Research Chair in Entrepreneurship Design, and she has designed an option for all of our programs, the students who are interested in entrepreneurship, how you start a company, how do you design prototype, how do you market it. Those who are interested in this, adding this option to their program, it's available all of our degrees that we offer in the school. Another option that we offer that is now particularly popular, or everybody is hiring in a discipline called data science, because currently, let's say in the last, 5+ years, maybe 5 to 10 years, there is tremendous amount of data that we generate by using all these social networks, by doing everything online. Of course, the companies want to analyze this data and based on this make some decisions. So there is a tremendous opportunity and tremendous amount of jobs available in this area. So we offer this as an option. So the students can have a computer science degree with, if you like, specialization in data science. In fact, this is becoming such a big area that it's warranting its own degree. So I'm going to get to that in the next slide. In addition, we also offer a joint bachelor's degree in computer science and mathematics. So they complement each other very well. So this is another fantastic degree to consider if you're interested. All right. In terms of languages, all of our courses, at least all of the courses in the school that are mandatory, all of the mandatory courses are offered both in English and French. So students basically have three options. They can take all of their courses in English. They can take all of their courses in French, or they can do the mix. And in case of doing this mix, or in case of taking some French courses, as long as they're taking a sufficient number of courses per semester that are in French, I believe it's 2 per semester or 3. Somebody surely can correct me. There's even an automatic scholarship for those who choose that option. So it's really completely up to students which of the 2 languages they want to take courses in. So here's some example. One of the best ways, by the way, to distinguish. So this option to study in all 3, to study in English and French or mixed is offered in all of our programs. So that's another example of something that is available to all the students in the school. So again, one of my goals for now will be to show you what are the differences between these degrees, these 4 degrees in particular. There is often in particular confusion between computer science, software engineering, and computer engineering. D3 in particular, there is a confusion. One of the good ways to distinguish them is look at the course sequence. So it's a good keyword to remember. You can put uOttawa, University of Ottawa course sequence. And for every program we offer, you can get a list of courses that a student, or at least mandatory courses, the students in particular program have to take. But just looking at the titles, and you can even find a description of these courses, you can figure out a difference between these courses. So let's look at some of the courses that you would be taking in computer science. You could take courses like in your 4th year, you can take courses such as artificial intelligence, data science, network, security, cryptography. So all of the, let's say, somehow in graphics. So as I mentioned, computer science has a tremendous number of applications. And one of the nice things about the program in computer science, and you can see that if you go to the course sequence, is that it has lots of flexibilities. There's quite a bit of choices for the students to make themselves. In the 4th year, it's basically almost all elective courses. By the time the students are in their 3rd year of computer science, they probably by then figure out which part of computer science they're interested and what are the topics that they would like to expand on. And then these can be the courses that they can choose for some of their electives in 3rd and 4th year. So for example, if they're interested in game design, they would take graphics courses. If they're interested in security, they would take security and cryptography courses. Of course, in data science, if they're interested, there's already course sequence for that and so on. So there's lots of flexibility and lots of choices for the courses to take. So some of the examples here are here, as I mentioned. So data science, artificial intelligence, networks, cryptography, computer graphics, data structures and algorithms, all the students take. These are the fundamentals of computer science and so on. As I mentioned, the co-op is available here. Some examples of salaries and placements. These are the placements from 2019. Almost 97% of the students were placed so they found the jobs, the co-op helped them find jobs. The salaries are very competitive, even on the lower end, they end up being about $3,000 a month. Okay, so software engineering, as I mentioned already, it focuses on kind of systematic way of designing software. Let's think of it as a management part. How do you organize a design of the huge software projects? Example of the courses for that, they align with that goal, something like analyzing requirements for the software, so software requirements and analysis, software design and architecture, how do you ensure quality, software quality insurance courses, analysis and design of user interfaces, how does your software, how do you present it to whoever is using it, and so on. So this is, in some ways, you can think of it even as a specialization within a computer science or within computer science and engineering. One unique thing about software engineering at University of Ottawa, unique in Canada, maybe there's one or two other universities in Canada that have it. I'm not sure, at some point I checked, but I'm not sure exactly which, is that this is the software engineering degree in computer at University of Ottawa is actually an engineering degree. So the students who take this degree, they're gonna become professional engineers once they get a degree and do that exams that engineer do to become PN. So they're on the path to become PN. So those who are interested in that software engineering program at University of Ottawa is unique in a way that it offers that that it's actually an engineering degree. Computer science is basically a science degree. It's not an engineering degree at the end of your discipline, at the end of your degree. So as you can see, this is indicated by this Bachelor of Applied Science. Those are engineering degrees. Okay, so the programs that we offer are Bachelor of Applied Science in Software Engineering. And of course, in that too, as I mentioned, you can add entrepreneurship option. Something that is another thing that is very specific to software engineering degree is that co-op is mandatory. So the students that get accepted to software engineering degree, they are in the co-op. So there is no option not to be in co-op if you are in software engineering degree. All right. So this is a new, before I tell you about computer engineering and electrical engineering, let me mention that we introduced a completely new degree called data science degree. It's basically a joint degree between mathematics and computer science. And the reason is that many of the most successful tools that are used in data science actually come from mathematics, and particularly from statistics. So this is a wonderful complement to have. And it's a degree with fantastic opportunities. Some of the example of courses that students would take is machine learning, which is the core of data science. Then they would have data science lab, artificial intelligence, fundamentals of data science, and so on. Okay, this is a new separate degree that we offer. All right, so what about computer engineering and electrical engineering? I would, if you think of computer science and software engineering as software disciplines, so as soft disciplines, I would think of these more as a hardware disciplines. So what do I mean by that? So if you like to program and design software, and this is what you're interested in, then computer science and software engineering for you. If you like to build things, if you like an actual machines and engines and want to see them working and moving, and then computer engineering is for you. Some of the examples of the things that computer engineering students and researchers and people at large, let's say, their jobs do. They design something like central processing unit, they design robots, they drive robots, and so on. There is also, let me actually go to that a slide about computer engineering, since I'm talking about computer engineering. There is also programming involved in computer engineering degree, but it's so-called low-level programming. The program, because all of the machines that you use, from the robots to Roomba, well, I guess Roomba is a robot if you have one of those vacuum cleaners that clean your house on your own, to your car, they all have software that is actually helping drive the machine in questions, from the computers to robots to cars. All of these machines, there is a special type of software that we call low-level software that is actually helping drive the machine and behave in the way that you want it to behave. And then on top of that, computer scientists and software engineers, they design software that is more, let's say, for humans, not for driving the machine. So for those who like to build things and to like to control them by doing this low-level programming, then computer engineering is for you. All right, so the degree, again, is an engineering degree, Bachelor's of Applied Science in Computer Engineering. Entrepreneurship option is offered, English, French options offered for all the courses. Well, except there's sometimes, let me be clear about this, that some elective courses may be offered, let's say, only in English, but this is not all the mandatory courses are offered both in French and English. All right, co-op is optional. So of all the programs that we offer, all of them have co-op optional. I already mentioned that, but except that in software engineering, co-op is mandatory. Again, it's very competitive computer engineering, very high placement, very good hourly salaries and monthly salaries. Some of the example of courses the student may take is computer system design, computer controls in robotics, digital image processing, much of the networks, in particular hardware network study of that, is within computer engineering. Okay, what about electrical engineering? Oh, by the way, before I forget, and I put this one, sorry, that was for electrical engineering, what I want to say. It's right here, I didn't forget it. Okay, so in electrical engineering, this is the area where I would also call it more of a hardware area, but you would study things like microwave circuits, electronics, optical networks. You want to know how do you generate signal, how do you propagate it. This you would learn in the courses such as wave propagation and antennas, optical communications, also networks, and so on. The electrical engineering also houses so-called studies in photonics. University of Ottawa is, you can see it here on the bottom. For me, the Zoom kind of blocks it. I hope it doesn't block it for you. We have a Center for Research in Photonics. University of Ottawa is one of the world leaders in the study of photonics. This is the study of light. And in terms of technology, a study of how do you generate light, how do you transmit light, how do you detect light, how do you use it in all of these applications, such as in optical networks for transmission of data, but then also biological applications, such as medicine, for example. So as I mentioned, we have some of the world's top researchers in photonics. So the students, specifically in their fourth year, can have a chance to take courses in this area. Basically, out of photonics, I think we have about 20 professors, and 15 or so have the highest level possible of professorship in Canada, so-called Canada Research Chairs. They are funded by the government. These are top research professorship positions that exist in Canada. So a majority of professors that we have in photonics are actually Canada Research Chairs. Not all of them are electrical engineers. Many of them are physicists, because obviously generation of light and study of light had a lot to do with the physics, which actually reminds me of another separate degree that we offer. And I'm going to go back to this electrical engineering, but let me just mention that we also offer a degree in physics and electrical engineering. It's a joint degree of these two disciplines. So basically students would get like a double degree, both in physics and electrical engineering, because again, there is a big interconnection in this discipline, and photonics is a perfect example of that. Some of the courses the students would take in this area would be quantum mechanics and microwave circuits and waves and optics and sustainable electrical power system and so on. To go back to electrical engineering degree, let me mention that even in this degree, although it's, I would say, more about hardware and signals and propagations of signals, that in all of these disciplines, at the end of the day, there is still a lot of application where the knowledge of programming and computer science is needed. For that reason, the students can basically, I didn't want to click on that. So what you see here is that they all have an option to choose computing technology as in addition to the electrical engineering degree. You can think of it as having, I wouldn't even say minor in computer science. This would be like doing electrical engineering and doing more like a major in computer science, doing an additional degree, or let's say half additional degree you would take in computer science, because you would still take most of the fundamental courses in computer science if you choose this computing technology option. It does add 1 year to the length of the studies. All right. So this is my summary of all of the programs that we offer. I'm going to now show you a little table and try through this table to show you what are differences, to summarize the differences between the programs. The way to read this table is the following. If on the left, I have some examples of disciplines, and to the right, the 4 degrees. And if it says high, it means if you want to study programming, then there is a high correlation with computer science, strong relationship with the computer science. So you should consider studying that, okay? And then you have medium relation and low relationship with these disciplines. So so let's start. If you're interested in programming, that computer science and software engineering are for you. In computer engineering, it says here the connection is kind of a medium correlation, and that's because, as I mentioned, you will have some programming on the low-level programming in computer engineering, and so in to some degree in electrical engineering as well. If you're interested in software design, then there is high connection with software engineering. Also to a lesser degree with computer science and computer engineering, and not so much in electrical engineering. If you're interested in databases, you want to study computer science and software engineering, not so much computer engineering and electrical engineering. Algorithms, this is the whole core of computer science. Algorithms are solutions, finding efficient solution to computational problems. This is what computer science is about. And to big degree, I would still say software engineering as well, not so much computer engineering and electrical engineering. If you want to study web technologies, you're going to see some of that in computer science and software engineering. If you want to see user interfaces, you're going to see that in some degree in software engineering, at least most of all these 3 programs. If you're interested in project management, so this is somehow the specialization within software engineering. I mean, software engineering focuses on that part of software design or managing huge projects, then software engineering is for you. If you want to study networks and communications, then you should look at computer engineering and electrical engineering. If you're interested in computer hardware, robotics hardware, and so on, then you have a high correlation with computer engineering. Then computer engineering is for you, and also to some degree electrical engineering, not so much computer science and software engineering. There is a couple of maybe courses that you would take in hardware. If you're interested in electronics, then electrical engineering is for you. Electronics and components of the computers, then electrical engineering for you. And as I already mentioned, and if you're interested in photonics and electrical system, then electrical engineering is for you. All right, so that's my summary about our programs. At the end, you can still ask me questions about that. I'm going to move to, let's see what I have next. Oh, by the way, about accreditation, that was another thing that I have. So all of engineering programs are accredited. So for those who are interested in getting a PEng at the end of the road, then software engineering, computer engineering, and electrical engineering are for you. Computer science is you getting a science degree. There is also accreditation for computer science, and all of our programs are accredited, both by the government and the professional association. In terms of flexibility of the program and choosing electives, I already mentioned that. Computer science is highly flexible. The other programs, because the engineering program, are less flexible because the Engineering Association of Ontario and Canada determine much of the mandatory courses in the program, so there's little space left for electives. There is some, but not as much as in computer science. As I mentioned, computer science, basically in the 4th year, they're almost all electives, okay? And management and entrepreneurship option are offered in all of our programs. Okay, so let me now change the topic and talk about what we do at University of Ottawa to try to make sure that we make your chances to succeed. Should you come to University of Ottawa and study in our programs, what do we do to make sure that your chances of success are as high as possible. And how do we help? I'm going to get out for the moment of here, and I'm going to try to explain what we do on every level, starting from professors all the way from the top of the university. Because if you choose to come to University of Ottawa, and in general, this is generally true, when you come to university, everybody wants you to succeed. Everybody, from professors in the courses to teaching assistants to the dean whose presentation you went to maybe earlier, to the top of the department, to the government. They want you to succeed. They want highly qualified personnel. They are funding university with that in goal. So everybody's goal is that you succeed in the program of your choice. So let me try to show you what we do at University of Ottawa to help you with that. And surely you want to succeed together with your family and so on. So let's see what we try to do about that. For myself as a professor, let me mention, by the way, that I'm teaching a first semester programming course. So if you choose to come to University of Ottawa and choose software engineering or computer science, you're very likely to see me in your first programming course. Equally, if you choose that computing technology option in an electrical engineering course and so on. So this is the course is actually called Introduction to Computing 1. This is this is a web page where all the information for the student is. So during the lecture, even when the lectures were live, obviously now in this very strange year, everything is online, all the lectures are online and so on. But even when all the lectures were live, a year ago or 2 years ago, when they were in person, I would try to give students all the possible resources they can succeed. For example, I would record every single lecture. I would give a live lecture, but I would also record it. I would put it online. So all the lectures are on YouTube. So you can see here when I go to lectures, all the material is posted. For example, lecture 3, you would see a lecture 3 video, slides of the lecture 3, and code that we do. So everything that we do immediately is posted, including the video. So if students couldn't make it to the class, or if they wanted to revise, review some material, it's available on the videos that I post. Even in this COVID time, I do, for example, live lectures. The student during the lectures, they can raise their hand. You can see in your Zoom, there is a little button where you can raise your hand. They ask question. I'm trying to make it as much as possible as a normal academic year, where the students have access to the professor and they can ask questions, and we all trying to do it. We all trying to do our best so that the students can get the best of the information and best of material education they can. Also, I want to make sure that the students feel that they can ask questions anytime, that they have access to a professor and ask them questions. So for example, if you go here to discussion board for everything that we are doing, okay, in the meantime, since I start giving this, there are 2 new questions that arrive. For everything that we're doing, I create a topic on the discussion board and the forum, and any time of day or night, the students can ask questions. Usually within an hour, I answer their questions. For example, you can see here that for assignment number 1, there were 252 threads or discussions. I answered all of them. So basically, there's 252 posts on 71 different topics. So I want to make sure that students still get access to the professor, they can ask questions and so on. So all of us try to do this to help students as much as we can. Then, in addition to professor, we get teaching assistants. And so when the students are working on something like an assignment, one of my main goals for my teaching assistant is to create lots of office hours. So for example, during the week, I make sure that there is at least 20 hours of office hours. So what that, in fact, this year, even on Saturday, I have office hours by some of the TAs who volunteer to do it on Saturday. Volunteer, they're paid, but I didn't want to force anybody to work on Saturday. So that means that students, when they're working on something like an assignment or preparing for a test, if at any moment during the week they have a question, well, kind of a week has a 40 working hours, there's 20 office hours offered. So basically at any one time, they probably have to wait at most 1 hour to actually join live office hours. Normally, they just walk to an office where the office hours are held and talk to the TA. And in this COVID year, we are doing it again live on the Zoom. They just connect to the Zoom. They can share screen with the TA. They can show them where they're stuck. The TA can help them and so on. So from the kind of lowest level, let's say, of professors and TAs, we're all trying to do our best to help the students. Then faculty of engineering itself is doing its own part. One of the things they're doing, and I believe the dean talked about it, is that they organize so-called mentoring hours. So for all the mandatory courses in the first year of engineering, they offer mentoring courses for each one of these mandatory courses. It should be somewhere here, should be schedule. I don't see it, but I believe it's 2 hours a week, where again, let's say for my course, the faculty of engineering organized that there are 2 hours a week where students can just join and ask any kind of help in this in the particular course, mandatory course. Unique thing about Mentoring Center is that it's actually undergraduate students that are the mentors for a particular course. So faculty of engineering hires, for example, for my course, the Introduction to Computing course, they will hire an undergraduate student that took my course a year before or 2 years before and did excellent in the course. So this is a perfect mentor, a perfect person to help new incoming students. And sometimes students feel more comfortable, the first year students, they may feel more comfortable talking to their peers, to other undergraduate students, than talking to teaching assistants, which are typically graduate students. So again, this is another level of help that students have. Mentoring Center doesn't only organize mentoring sessions for the mandatory courses, they also organize sessions to help students work out. How do you work out with your time? How do you succeed? How do you have some balance between your studies and life and so on? So these type of success centers and mentoring centers are available to students, as I mentioned, at every level of universities. And those who do well, the opportunities are wonderful, even during their undergraduate studies. So especially in our disciplines. So let me mention some of them. So the students who are doing well, there is Natural Science and Engineering Research Council of Canada. Basically provides all the research funding, majority of the research funding in science and technology in Canada. And they already want to engage students, undergraduate students, to do research. So for those students who are doing well, there are some opportunities for them to do undergraduate research and actually get undergraduate research fellowship. So all the students can apply for that already in the first year. And of course, those who are doing the best, these opportunities will be open for them. The award is called USRA. And these are fantastic awards that the top employees also recognize these. They're well aware that these are the best students who get these, and this is a fantastic thing to have on your CV. USRA awards are available to Canadian students and permanent residents, but University of Ottawa has kind of an equivalent one that is open to all University of Ottawa students, including international students. So that one is called Undergraduate Research Opportunity Program. It's called Euro program. So for students who are doing well, there are also research opportunities, paid research opportunities for summer and sometimes even during the semester. One thing, I just closed it. One thing I also want to mention, within a computer science, the students who are doing well should consider so-called accelerated masters. We offer accelerated master's program in computer science, What that means that normally computer science program is 4 years long. And if you want to do a master's degree in computer science, that's additional 2. But the students who are doing well in their 3rd year, and if they're interested in doing masters and trying out research, in their 3rd year, they can apply for accelerated master. In that case, in their 4th year already, they can take some of the graduate level courses and in many ways finish much of the course requirement for the masters. And then in their 5th year, they can start doing their research and working on their thesis, and they can get both undergraduate and a master's degree in computer science in 5 years instead of what is normally 6. So these are some of the opportunities that are available to the students. All right, so let me see. COOP, as I mentioned already. COOP is available in all of our program. Let me just show you one of the, I'm gonna get there quickly. One of the typical sequences the students follow. Okay, so in majority of our programs and majority of the students will follow this sequence that you see on the left. So in their 1st year, after the finish of their 1st year is, in their 1st summer, they are free, or they can take extra courses or do whatever they like or find their own job. But the co-op starts in the 1st summer after their 2nd year. And then they alternate with 1 semester of work, then 1 semester of study, 1 semester work, study, and so on until they get their degree. So typically in a 4-year program, the student would get their degree in 4 years and 4 months. But within that, you see they would have 1 year and 4 months of work experience. So this is really great because these jobs, the co-op is part of the degree for the students who are in the co-op. So these jobs they have to be in the disciplines that students are studying. So this is this type of work actually enhances the student's knowledge. And in addition, a student gets work experience and they get paid. And in this area, we are lucky that there's a lot of jobs and the pay is very good. And in addition, students also make a network and connections and very often go back and get their permanent jobs from one of their co-op employers. Some of the students, they do all 4 terms in different companies. Some of them really love so much the first company they did their co-op in, and they do all their term in co-op and so on. A great thing about Ottawa is that it's really a hub for high-tech companies. But in addition, the government is in Ottawa. So there's many jobs, both in public and private sector, that there are many jobs where they're hiring co-op students. And once the students get their degrees, I forgot the last statistic, but it was something like, if you get a computer science, software engineering, electrical engineering, computer engineering degree from our faculty, it's something like 99% of the students get permanent job within 6 months of getting their degree. So it's a fantastic investment in studying. It's in many ways, for those of you who are interested. So this is what I'm going to end with. I want to show you. I want to show you a table, or basically statistics from about our disciplines, these disciplines, and it's from an economist, from the Economist magazine, that from, I don't know, a couple of years ago. And it has an interesting title I would like to show you. The title of the article is, you can't see it here, but and you can find the stats on your own. It's Revenge of the Nerds. So all I wanted to show you actually is the stat here. So what do you see here? These are all the degrees across all the disciplines. I'm not talking only now about engineering discipline. I'm talking about science and arts and economics, and so on. So if you look at, so what they were looking at is how much does it pay off to study something. So you can think of your degree as a form of investment. First of all, it takes you 4 years of your life. You pay for it, and you also, not only that you pay for it, but also you don't have income from this for compared to if you went to find a job after 4 years of high school. So you can think of it as a form of investment. So what you want to know when you invest in something is what is the rate of return. So if you're investing in the stock market, in the bank, a really good rate of return would be, for example, 7 or 8%. 7, 8%, that means 7, 8%, 9%. I forgot exactly what. I did these calculations, but that means in every 7 years, you're doubling. So if you invested, I don't know, $100,000 or $10,000, in 7 years, you're going to have 20,000. In 14 years, you're going to have 40,000 and so on. Exponential growth. Every 7 years, you're doubling so 7% and above is great rate of return. Okay. So what you see here on x-axis, you see that, let's say on a y-axis, you see rate of return from various universities studying various disciplines. On the x-axis, you see the admissions rate of various universities. Okay, so what we see here, admission rate, so the smaller admission rate, you would think this is more of a top school and a highly competitive school that would have a smaller admission rate than some other schools. So here you see some of the rate of returns are 15%, 10%, and so on. There's so many that some of them are even negative rate of return, unfortunately. So let's look at engineering, computer science, and math discipline. They are all on the top. These are these blue points. A rate of return, basically, it seems to be most of it is above 10%. So it's a great rate of return on investment. Unfortunately, some other disciplines, it's not like that. Some of them are even in the negatives. So if this is a discipline that you're interested in, you should consider yourself lucky because opportunities are tremendous and the return of your investment is tremendous. So since I see Julie, I assume that this means that I should stop.
Well, we only have a few minutes left, so.
Okay, let me then add one more thing. This discipline, I want to add just one more thing. Not only that you're going to get a great rate of return on an investment, which typically means that you're going to have a high salary. And you can Google easily and find out the salary. They're fantastic. And of course, not everything is about money, but life is typically better if you have it. But one thing I would like to point out is that if you look at this rate of return for electrical engineering and computer science and math, you would expect that the curve goes down like this, that the return is bigger on the highly competitive, if you're coming from highly competitive universities, and is going down if you're getting to lesser competitive university. Because remember, on an x-axis, you have acceptance rate of university. And actually, that's not the case. It looks pretty flat. And that's another wonderful thing about these disciplines, that these are kind of equalizing disciplines. That if you learned what you're supposed to learn, there's so many opportunities that it doesn't even really matter that you're going to get a great investment and return on your investment. You're not going to need connections from your family or friends to get fantastic job and to succeed. So that's what I'm going to stop at.